Alright, so let's start looking at my TinkerCAD design here, named the Fantabulous Bidgerigogo. Open it up. Okay, so here we got 3 ultrasonic sensors with the 4 pins. We got each of the trig and echo pins wired into various analog or the digital pin connectors on Arduino here, just so that way they're able to send out the pulse and then receive it in, calculate the distance to various obstacles. Then we have just for the purposes of powering this, we have 2 9-volt batteries. In a scaled up version it would probably be a different power source. But just to get this to work here in TinkerCAD, we use the 2 9-volts. Then we have 4 hobby gear motors, 1 for each wheel. This upper side here would technically be the left side, and the lower side will be the right. This here would be the front. Everything here is all wired together to have the 5-volt power, and that connects to all the enable pins and for both sides of the L2 93Ds. All the grounds are connected to the same spot, and then I have the input-output pins all set to analog or the PWM pins on the Arduino, so that way we can power those, tell the DC hobby gear motors to turn on and off. Then we have our code here. At the top I just have variables for all of my various pin numbers that are used, so we can change those in one central location. Then we have the variables for the distance from the front, left, right, and the time to receive the pulse from the front, left, and right. You have your void setup here for setting up all the printer for the serial monitor, and then setting up all the input-output pin modes. Then down here in the loop you have a you're constantly checking the distance from the front. Then if it's less than the 20 inches or 20, then it's going to, or greater than, sorry, it's going to move forward and print out a message down here on the serial monitor, just for proof that it's working, the distance from the front. If it's less than 20, then it's going to print that just slightly differently, just for formatting's sake. And then it's going to check the distance from left and the distance from right and print those out. And if the distance from the left is less than 20 and distance from right is less than 20, it'll go in reverse. If its distance from left is distance from left is less than 20, then it will turn off the right motors and turn to the right, and then same for the right, and then otherwise it's just going to keep going forward. So let's do a quick simulation of this. So as you can see here, my front is at 32, so it's just printing it out, and all my motors are going forward. If I drop this to under 20, it prints front, left, and right. And if I make my left under 20, you can see that the right motors turn off, so it should pivot, and then do that for the other side. So then the left motors turn off, so it should pivot. And if I actually have both of these under 20, then it goes in reverse. And then as soon as this front is over 20 again, they'll kick back into forward. And so it should be able to navigate the entirety of an area without hitting any obstacles, through pivoting, stopping, reversing, turning left or right.